Hello student, welcome to this video. This is lecture number 17. We already covered up lecture 16, 1 to 16 for solving the supplementary problem of the book vector analysis by M.R.Spiegel. And this is important book for the physics honors as well as for mathematics honors, and you know this is a most important book for the IIT JAM examination also. That's why we decided to solve the supplementary problem of this book. Today we want to solve the supplementary problem 3.40 to 3.46 of the chapter 3, which is the vector differentiation. So let's go to today's question. Question 3.40 says the solution of this general solution, so that the general solution of differential equation where alpha and r the this. You know the auxiliary equation of this differential equation nothing but the auxiliary equation of differential equation nothing but this is the m square plus 2 alpha plus omega square is equal to 0. So what is the value of m? Also 2 alpha m, 2m alpha, this is 2m alpha. What is the value of m? This is minus a minus b, that is minus 2 alpha plus minus root over b square, that is 4 alpha square minus 4 ca by 2a. So this is nothing but the minus alpha plus minus root under alpha square minus omega square. Okay, so now comes into the condition. First condition, when if alpha square minus omega square is greater than 0, that means this is real and the roots are minus alpha. M1 can be written as minus alpha plus root under alpha square minus omega square, and M2 can be written as minus alpha minus root under alpha square minus omega square. So the solution will be like that. R vector is nothing but some constant called C1 e to the power M1 t plus C2 e to the power M2 t. Now put the value of C1 and C2, and C1 and C2 is the arbitrary vector constant. C1 e to the power M1 t, that is minus alpha t into e to the power root under alpha square minus omega square t, plus C2, this is C1, and plus C2 e to the power minus alpha t into e to the power minus root under alpha square minus omega square t. So this is nothing but e to the power minus alpha t within bracket c1 vector e to the power root under alpha square minus omega square t plus c2 e to the power minus root under alpha square minus omega square into t. Now come into the second condition where alpha square minus omega square is less than 0. That means this will be negative. This can be written as, if this is negative, then the solution can be written as since this will be negative, the solution can be written as the real part is the alpha t and the c1 cos omega square minus alpha square t plus c2 sine omega root under omega square minus alpha square into t. And for if these two are equal, that means alpha square minus omega square is 0, then the roots are equal, then the solution can be written as the into the minus alpha t c1 vector plus c2 vector t into e to the power minus alpha t. Okay, this is the solution for if these two are roots are equal. So this is the actually solution of the differential equation problem. Next, to go to the next question. Solve this. So for a, the auxiliary equation nothing but m square minus 4m minus 5 is equal to 0. This can be written as m minus 5 into m plus 1, that is 0. This becomes m is 5 and minus 1. So the roots are real and unequal, so we can say the solution will be like that, some constant e to the power 5t plus another some vector constant e to the power minus t, where a b are the arbitrary vector constant. Next, the auxiliary equation m square plus 2m plus 1 equal to 0. So this will be m plus 1 whole square equals to 0, that's mean m equals to -1 -1. The roots are real and equal. Since the roots are real and equal, we can say the solution will be a plus bt e to the power minus t. Then number 3, d2r, that means the auxiliary equation will be m square plus 4 equals to 0, that is m square equals to minus 4, that is m equals to plus minus 2i, that is the roots are complex conjugate, so we can say the solution will be like that. The real part is 0, so the solution will be a vector sine 2t plus b vector cos 2t. Okay, this is the solution of this. Go to the next question. Solve this equation, put the value dy dx. So dt of y is nothing but minus dx vector dt equal to x vector. So this will becomes d2x minus d2x dt square equals to x vector. So this will be d2x dt square plus x vector equal to 0. The auxiliary equation will be m square plus 1 equals to 0. So m equals to plus minus I. So the solution will be some constant sin t plus another constant cos t. If we know the value of x, then we can say y equals to minus dx dt. So if you derivative this will be become minus a1 cos t minus sub minus plus b1 sin t. Okay, this is the solution of this question. Go to the next question. Suppose a vector equal to this, find this. Okay, so del a del x, that means partial derivative with respect to x, that will becomes minus y sin xy I cap with respect to x, the derivative will be plus 3 minus 4x j cap plus 3y minus 4x j cap with respect to x, this is 3 k cap. Then a vector by del y, so derivative with respect to y, that is minus x sin xy I cap with respect to y, this is the 3x j cap with respect to y, that is the minus 2 k cap. Del to a del x square, that means with respect to x you get the minus y again, so minus y square cos xy I cap with respect to x, this is the minus 4 j cap, and this term is 0. And similarly for with respect to okay, similarly del to a del y square, that means with respect to y you get the minus x square cos xy with respect to y, this will be 0. Similarly del to a del x del y, so differentiate with respect to x you get and you know the with respect to x, that is minus sin xy, and with respect to x plus x and y cos xy, right, into I cap, and with respect to x this will become 3 j cap, and you know this will be equals to del to a del y del x. Go to the next question. Suppose a vector equal to and b vector equal to this, find this vector. So you must go to the a cross b. A cross b is nothing but the I cap j cap k cap. The coefficient are x square yz minus 2 xz cube and xz square, and this is the 2z y minus xs cube I cap. This and this vector are product at 2xs cube z cube, 2xs cube z cube minus xy z square minus j cap. Product is minus x to the power 4 yz minus this product becomes 2xz cube plus k cap. This is nothing but x square y square z, and this is plus 4xz to the power 4. Okay, this is a cross b. Now you need to partial derivative del x a cross b is nothing but, if we partial derivative with respect to x, this will becomes, with respect to x, this will become 6x square z cube and minus y z square minus j cap, and this can be written as plus. So x to the power 4 means 4x cube yz minus plus 2 x, so that is z cube plus k cap. With respect to x, this will be 2x y squared z, and this is 4 z to the power 4. And again, if we derivative with respect to y, so del 2 del x del y a cross b. So if we respect to y, this will be 0, this will be minus 1, so minus z square I cap. With respect to y, this will be j cap. With respect to y, this will be 4x cube z, and this will be 0. And with respect to y, this become 4xy z, and this will be 0. So at 1 0 minus 2, if we put this value, z is minus 2, that is minus 4 I cap, and z is minus 2, x is 1, that is minus 8 j cap. When y is 0, this will be 0. So that answer of this question is minus 44. Answer of this question is minus 4 I cap minus 8 j cap is the correct answer. Go to the next question. Suppose C1 C2 the constant, lambda is the constant, scalar constant, so that this is okay. So find out the del h del x. What is the value of del h del x? E to the power minus, so minus lambda e to the power minus lambda x C1 vector sin lambda y plus C2 vector cos lambda y. Okay, del 2x square, if we again derivative, so this will be lambda square e to the power minus lambda x C1 sin lambda y plus C2 cos lambda y. Now derivative del h del y, if we derivative with respect to partial derivative with respect to y, this will become minus lambda x, and this is the C1 vector cos lambda, there will be lambda cos lambda y minus C2 vector, there will be lambda sin lambda y. And again, if we derivative del 2 h del y square, there will be another lambda, so if we take lambda square as a common, so this will be e to the power minus c1 vector sin lambda y minus c2 cos lambda y. So if we take minus as a common, then you can say this is the minus del 2 del x square. If this is in left hand side, you can say del 2 h del x square plus del 2 h del y square equals to 0. Hence prove the equation. Go to the next question. Suppose P0 is a constant vector, omega c are the constant of the class. Prove that A is the satisfy this equation. So you need to find out this partial derivative and prove this relation. So A del A is nothing but P0 e to the power I omega within bracket T minus R by C total by R, right? So what is the value of del A vector by del R? So this will be minus 1 by R square, that is minus 1 by P0 by R square to the power I omega t minus r by c, and plus p0 by r, and this will be I omega minus 1 by c e to the power I omega t minus r by c. And if we again derivative this, del 2 a del r square is nothing but minus 2, this is plus 2, 2 p0 by r cube with the power I omega t minus r by c minus p0 by r square, and derivative of this is I omega minus 1 by c with the power I omega t minus rc. Okay, and this derivative is nothing but minus p0 by r square I omega minus 1 by c to the power I omega t minus r by c, and derivative of this again we can return as the p0 by r into the p0 by r I omega minus 1 by c, and this also whole square e to the power I omega t minus r by c. Okay, so and there need to add partial derivative with respect to t. If we derivative with respect to t, you can say this will be p0 by r e to the power I omega t minus r by c, and you get a I omega, and the double derivative del t square. Okay, this is another I omega, so the minus omega square p0 by r to the power I omega t minus r by 2. Okay, so the left hand side of this expression you can say, left hand side of this expression you can say del 2 a vector by del r square plus 2 by r vector del a del r. This is nothing but uh, this expression and 2 by r, 2 by r, if you uh, 2 by 2 by r multiply 2 by r, that's mean you need to multiply, I just write down here 2 by r, that's mean you need to multiply 2 and r, so this will be r cube, this will be r cube, and 2 by r, this is r square, 2 by r. Okay, so if we add these two, if we add this expression and that expression, you can say this will be cancel out, and this term also be cancel out. Okay, this term, these three term also cancel out, you will get only this term, so you can write p0 by r, p0 by r, this is will be minus I square, this is minus I square is minus 1, so minus plus omega square by c square, this will becomes omega square by c square, and this is nothing but e to the power I omega this term, so this will be e to the power I omega within bracket t by c t minus r by c. Okay, and you can see this is the so there will be a sorry minus, there will be a mistake of minus, I think there is a mistake of minus, yes there is a minus 1 by c, no I square I omega I square I omega is minus 1, that is correct. Okay, so this can be written as p0 by r e to the power I omega t minus r by c, this is nothing but the a vector, right? So this is nothing but the a vector, this is actually minus omega square a vector, and this is nothing but omega square by c square a vector. There is a mismatch of c square, so this will be written as and this will be 1 by c square del 2a del t square. I think there is a mistake of, there is a mismatch of minus. This minus is here. I think there should be a negative sign in this expression. There should be a negative sign in this expression. This minus must be included, I think. This is a whole square, so I square gives you minus sign. Right. There is a minus sign. So hence proved. Hence this will be equal to that. Del 2a del r square plus 2 by r del a del r. Right. Okay, hence this proved. Thank you. This is all about me, and this is my contact details. You can contact with me by WhatsApp or Telegram for regarding the physics related question. And this is my YouTube channel. You can subscribe this channel for getting this notification. You press the bell icon. Thank you. We will meet in the next video as soon as possible. Take care.